Right, diffraction. Diffraction is basically the spreading of waves when going through a gap. This can happen to sound waves, to light waves, to earthquake waves. So an example we have here is we have the blue lines represent waves, okay, at sea, and they represent the tops of waves or the crests of waves. And as these waves hit an obstacle, let's imagine a pier or whatever, they spread around it. Now, on the right-hand side, you can see it gets spread a little bit, but on the left-hand side, you can see it spreads an awful lot. And the reason why that's the case is that the waves will diffract more or spread more when the gap is of a similar size to the wavelength. Okay, so on the left-hand side, because the gap is the same size as the wavelength, it spreads a huge amount, whereas on the right-hand side, it doesn't spread quite so much. An example of this is, for example, if you have, you can hear sound going around corners, even though you can't see them. It's because the sound has a wavelength similar to the physical space around where we hear. Another example might be things like television signals from a mast, and that when they go over an obstacle like a hill, they will spread out or diffract. Sometimes they might not diffract enough, so that's sometimes a common question is, why can this house not hear it? It's because the sound waves, or sorry, the television waves haven't refracted enough. And what's actually happening in this case here is, you may have done this in school, where a laser beam is fired at a very narrow gap, sometimes called a diffraction grating. Sometimes people use DVDs, for example, and when the laser goes through it, it then spreads out a fair bit, like you see there. And that there is diffraction.